So we are dealing with the sixth problem in this segment, and the sixth problem is problem number 1.83. The problem is suggesting a particle of mass m moves along a circle of radius r. Find the modulus of the average vector of the force acting on the particle over the distance equal to a quarter of the circle if the particle moves uniformly with the velocity v, and in the b part with constant tangential acceleration a, the initial velocity being equal to 0. So let us first understand. So to understand this problem, let us consider a circular path like this, and in this circular path we are dealing with the quarter of a circle. That is, the motion commences here at t equal to 0. The particle starts from here, and it is here at the end of a certain time t. Now over here, if we consider it from the point of view with a uniform velocity, so if the velocity is uniform or speed is constant, so if it is moving with a constant velocity, then at t equals 0, the velocity is directed in this direction. And if the particle moves like this, then at this highest point, so the final velocity is in this direction with a velocity v. So this one is final velocity and this one is initial velocity. And over here, if we think in terms of the change in velocity, so this is final velocity, this is initial velocity, so final minus initial will give us the change in velocity. So delta v is equal to v final minus v initial, or which we write over here as u. And since both these magnitudes are same, equal to v, so we write this magnitude v as root 2v. Now in order to conduct this motion, it will take a time t by 4, where t is the total time to cover the entire circle, that is 2 pi r by v into 4. So we write it as pi r by 2v. So this is the time in which the total motion is commenced or completed, and therefore if we calculate the average value of force, then the average value of force can be written as the change in momentum by time taken, delta p by delta t, so m times of delta v by delta t, and over here on solving we obtain this as 2 root 2 mv square by pi r. So this is the average velocity of force that we have. Now in the second part of the problem is asking us if it is moving with a constant tangential acceleration. So I've already stated in the previous problems that if the tangential acceleration is constant and it starts with 0 initial velocity, so in this certain amount of time it will attain a final speed at. Therefore over here we write it as for the second part of the problem, so we write the initial velocity being 0 as given in the problem, and the final is equal to at. And in this span of time it took a time delta t, and therefore if we calculate f average from this point of view, then this is equal to delta p by delta t, and therefore we get the value equal to ma, where a is the tangential acceleration of the particle. So this is how we solve this problem, which is problem number 1.83.